In 1943, German military engineers completed what many consider the most formidable tank of World War II, the Tiger I. It was faster than anything the Allies could field. Its armor was thicker. Its gun was more powerful. In direct tank-to-tank combat, a single Tiger could destroy 3 or 4 American Shermans before being destroyed itself. Yet Germany lost the tank war. Decisively. Completely. The nation that produced the superior tank was defeated by the nation that produced more tanks. This is not a story about brave soldiers or brilliant generals. This is a story about mathematics, industrial capacity, and a fundamental truth about modern warfare. The side with 10 good weapons beats the side with 1 perfect weapon every single time. The Tiger I tank symbolizes this truth more perfectly than any other weapon system in World War II. It is simultaneously history's most formidable tank and history's greatest example of how superior quality means nothing without sufficient quantity. The Tiger I emerged from German tank development in 1942. Every specification reflected engineering brilliance and operational experience. The tank weighed 54 tons compared to Sherman's 30 tons. Tiger armor reached up to 100 millimeters thick compared to Sherman's 50 millimeters. The main gun was an 88 millimeter compared to Sherman's 75 millimeter. The engine produced 700 horsepower compared to Sherman's 400 horsepower. The crew consisted of 5 personnel. The effective combat range was 1,500 meters, allowing engagement at distances where the Sherman's 75 millimeter gun couldn't even scratch Tiger armor. The 88 millimeter gun was revolutionary. It had been designed as an anti-aircraft weapon, then adapted for tank use. The gun could penetrate Sherman armor at distances where the Sherman's gun couldn't even reach the Tiger. In direct engagement, the Tiger's advantage was overwhelming. German tank crews reported typical engagement scenarios that showed this dominance. A Tiger I commander spots a Sherman at 1,200 meters. The Tiger gunner takes aim. One shot. The 88 millimeter round travels at 790 meters per second and strikes the Sherman's side armor. The round penetrates easily, ignites ammunition, and the Sherman erupts in flames. The Tiger crew never hears return fire because the Sherman's gun cannot effectively engage at that distance. This scenario repeated throughout the war. Tank Commander Hans Schroeder of the 1st SS Panzer Corps documented in his after-action report. In engagement near Villers-Bocage, 1 Tiger destroyed 5 Shermans in sequence. American crew officers attempted to circle the Tiger, but the armor defeated all anti-tank strikes. The Tiger was destroyed only by coordinated artillery fire and infantry anti-tank weapons after all 5 Shermans were destroyed. German military records show that Tiger I tanks achieved kill ratios of approximately 8-to-1 against Shermans in direct engagements. That is, 1 Tiger killed an average of 8 Shermans before being destroyed. Against this, Sherman crews reported that they needed 3 or 4 Shermans attacking simultaneously to have a reasonable chance of destroying a Tiger. Even then, the kill ratio heavily favored the Tiger. The Soviets, who faced Tigers on the Eastern Front, conducted detailed analysis. Their conclusion stated, "The Tiger I is the superior tank in any direct engagement. Multiple T-34s must be committed to achieve kill probability against a single Tiger. The Tiger is tactically decisive in local engagements." The superiority was not accidental. It resulted from deliberate German design choices. The Tiger I used sloped armor, angled to increase effective thickness. A 75 millimeter round that would penetrate perpendicular armor would ricochet off sloped armor. The psychology of facing the Tiger was devastating. American tankers knew their guns couldn't penetrate the front armor at any realistic distance. The 88 millimeter gun was not just more powerful, it was a qualitatively different weapon. It could engage targets beyond the engagement envelope of Sherman guns. This meant Tigers could destroy Shermans from ranges where the Shermans couldn't respond. German tank crews were, on average, more experienced and better trained. A Tiger crew could achieve first-shot kills at distances where a Sherman crew would require 3 or 4 shots. German manufacturing standards meant Tiger tanks were more reliable than Shermans. Tiger I tanks had fewer mechanical failures and longer operational lifespans. General George Patton, commander of the American Third Army, wrote in his personal diary after encountering Tigers, "The German Tiger tank is superior to any American tank in existence. Our Shermans are outgunned, outarmored, and outmaneuvered. To defeat Tigers, we must employ multiple Shermans in coordinated attacks or use anti-tank guns and artillery. Head-to-head tank combat against a Tiger is a losing proposition for our crews." Yet Patton also wrote something more significant. The answer to the Tiger is not a better tank. The answer is more tanks. The Sherman tank represented a fundamentally different design philosophy from the Tiger. American engineers did not attempt to build the most powerful tank. They attempted to build a tank that could be produced in enormous numbers while remaining operationally capable. The Sherman M4 weighed 30 tons. It had 50 millimeters of maximum armor. The main gun was 75 millimeter, later upgraded to 76 millimeter. The engine produced 400 to 500 horsepower gasoline or diesel. The crew consisted of 5 personnel. The production numbers are staggering. For every Tiger I tank Germany produced, the United States produced 36 Shermans. Total Sherman production reached 49,234 tanks in all variants by war's end. Total Tiger I production reached only 1,347 tanks. American tank production was not about perfection. It was about standardization, mass production, and replaceable parts. Every Sherman was built to identical specifications. Parts were interchangeable. A turret from one factory could be mounted on a hull from another factory. Sherman design prioritized ease of manufacture over technical sophistication. The 75 millimeter gun was simpler to produce than the 88 millimeter gun. The armor layout, while less effective than Tiger armor, was easier to manufacture. Sherman tanks could be quickly repaired by swapping components. A damaged engine compartment could be replaced in hours. A damaged turret could be unbolted and replaced. If a tank broke down, a replacement was available within days. American tank crews reported that Shermans were less reliable than Tigers individually, but American logistics ensured that losses were quickly replaced. American manufacturers continuously improved the Sherman. The 75 millimeter gun was upgraded to the more powerful 76 millimeter gun. Armor was thickened in specific areas. New variants appeared regularly. American tank designer Colonel Robert T. Brown explained the design rationale in a 1946 interview. "We knew we couldn't out-engineer the Germans in tank design. What we could do was outproduce them. If they build one perfect tank, we build 10 good tanks. If they destroy 5 of ours, we have 5 left. If they destroy 5 of theirs, they have fewer than before." Annual tank production comparison reveals the disparity. Germany produced 4,890 Panzers of all types in 1944 and 2,100 Panzers in 1945. Total Tiger I production reached only 1,347 tanks for the entire war. Meanwhile, the United States produced 17,000 Shermans in 1944 and 8,000 Shermans in 1945. Total Sherman production reached 49,234 tanks. The Soviet Union produced 19,000 tanks in 1944 and 15,000 tanks in 1945, for total production exceeding 105,000 tanks. The numerical disparity was overwhelming. Germany was outnumbered by factors of 10, 20, and sometimes 50 to 1 in total tank production. But the numbers tell only part of the story. The real story is about what these numbers meant operationally. In a hypothetical engagement on a specific day in July 1944, American forces commit 100 Sherman tanks to attack a German defensive position held by 10 Tiger I tanks. Based on historical kill ratios, Each Tiger I destroys an average of 8 Shermans before being destroyed. 10 Tigers destroy 80 Shermans. American forces lose 80 tanks. German forces lose 10 tanks. American kill ratio is unfavorable at 1:8. However, American tank production for that month is 1,400 Shermans. German tank production for that month is 40 Tiger I tanks. Within 30 days, America has replaced its losses twice over. Germany has lost 10 tanks and produced 40 new ones, a net gain of 30 tanks, but still 70 fewer tanks than it started with. In the second month, America commits 100 Shermans again. Germany commits 25 Tigers. Same kill ratio, 25 Tigers destroy 200 Shermans. American losses are 200. German losses are 25, but America produces 1,400 new Shermans. Germany produces 40 new Tigers. After 2 months, American tanks have grown from 500 to 3,020 tanks, a six-fold increase. The German tank force has grown from 50 to 95 tanks, less than a two-fold increase. Yet the German tanks are superior individually. This is the mathematics of industrial warfare. German panzer forces in October 1944 included approximately 2,470 total operational tanks, with 140 Tiger I tanks, 310 Panther tanks, 1,200 PZ-4 tanks, and 820 older types. American tank forces in October 1944 included approximately 8,900 total operational tanks, with 7,200 Shermans and 1,700 specialized tanks. The numerical ratio was 3.6 to 1 in America's favor. But the operational reality was worse for Germany. By October 1944, American tank production was at 1,200 plus Shermans per month. German production was declining because losses exceeded production. The ratio was widening, not narrowing. German General Otto von Manschufel analyzed the situation in his October 1944 report. The enemy possesses not merely numerical superiority, but superiority that increases each month. Our Tiger tanks are superior in individual combat. This is irrelevant. We face an enemy who can lose 100 tanks and have 100 new tanks within a week. We lose 10 tanks and cannot replace them for a month. The mathematics are immutable. The Tiger I, for all its technical superiority, had critical vulnerabilities that the numbers couldn't overcome. The Tiger I used a Maybach engine and Lanz transmission that were powerful but fragile. In extended operations, mechanical failure rates were high. German maintenance records show that approximately 30% of Tiger tanks were non-operational on any given day due to mechanical issues. Sherman tanks had less powerful engines but more reliable transmissions. American maintenance records show approximately 15% of Shermans were non-operational on any given day. This meant that while a Tiger was superior when operational, Shermans were more reliably available for combat operations. Tigers consumed fuel at approximately 1.3 kilometers per liter. Shermans consumed fuel at approximately 1.7 kilometers per liter. In an environment of fuel scarcity, which Germany faced increasingly from 1944 onward, this meant each Tiger consumed resources needed for multiple Shermans. By late 1944, fuel was Germany's primary constraint. A Tiger tank consumed the equivalent fuel of 3 Shermans for the same operational distance. A Tiger tank required approximately 300 man-hours to produce. A Sherman required approximately 150 man-hours. This meant that in the time German factories produced 1 Tiger, American factories produced 2 Shermans. Tigers were crewed by highly trained, experienced soldiers. Shermans were increasingly crewed by hastily trained replacements. However, American training pipeline produced thousands of replacement tank crews per month. German training pipeline produced hundreds. A Sherman crewed by an inexperienced crew was inferior to a Tiger crewed by an experienced crew. But America could accept this disparity because it could replace losses faster. Tigers were vulnerable to coordinated infantry anti-tank weapons. American infantrymen with bazookas, coordinated with artillery, could destroy Tigers. Sherman tank crews, despite inferior firepower, could support infantry more effectively because there were more Shermans available to provide covering fire. German tankers understood the superiority of their tanks. This created a psychological advantage in individual engagements, but a psychological disadvantage in strategic perspective. German tank commander Karl Radke recorded in his diary, "We are invincible in combat. In every engagement with Shermans, we prevail. Yet we grow fewer. Every Sherman destroyed is replaced by another Sherman within a week. Our tanks are destroyed and cannot be replaced for months. We are winning every battle and losing the war. This is a war of mathematics, not of courage." American tankers knew their tanks were inferior individually. This created tactical caution, but not strategic despair. American soldiers understood that their advantage was not individual superiority, but collective availability. American tank crew commander James Hardin wrote after the war, "We knew every Tiger was more dangerous than any Sherman. We compensated by being more numerous, better supplied, and replaceable. When we lost a Sherman, we knew a new one would arrive in a week. When we lost teammates, we knew replacements would arrive. This knowledge gave us confidence despite individual inferiority." The American approach to tank warfare was fundamentally different from the German approach. Americans did not attempt to win individual tank engagements. Americans attempted to win campaigns. American tank doctrine used quantity as tactic, employing multiple Shermans to overwhelm Tiger positions rather than trying to outgun individual Tigers. Coordinated support used artillery, infantry anti-tank weapons, and air power to neutralize Tiger tanks rather than defeating them in direct combat. Logistics became strategy, ensuring that for every tank lost, 2 new tanks were available within the week. Operational tempo was maintained through accepting higher individual tank losses in exchange for maintaining continuous operational pressure. Attrition warfare was deliberately chosen, with higher casualty operations accepted knowing that American industrial capacity could sustain losses that German industry could not. German tank doctrine attempted to concentrate superior force to use Tiger concentrations to achieve local breakthroughs before American numerical superiority could be brought to bear. Tanks were preserved in defensive positioning to minimize losses, knowing replacement production was minimal. Each Tiger was maximized for individual performance to ensure that each Tiger killed multiple Shermans, maintaining favorable kill ratios even as tank numbers declined. These doctrines were fundamentally incompatible. German doctrine preserved tanks in the short term but guaranteed eventual exhaustion. American doctrine accepted short-term losses but guaranteed eventual victory through attrition. The German Ardennes Offensive, also known as the Battle of the Bulge, in December 1944 represented the last major German attempt to use tank superiority to achieve strategic victory. German forces committed approximately 1,400 tanks, including heavy concentrations of Tiger and Panther tanks. The offensive was intended to break through American lines and reach Antwerp, splitting the Allied army. For the first week, German tank forces achieved tactical success. Tiger tanks, concentrated in specific sectors, destroyed numerous Shermans. Kill ratios favored the Germans. But American forces responded with devastating artillery bombardments, airstrikes, and coordinated multi-tank attacks. The German offensive stalled after 10 days. German tanks lost in the Battle of the Bulge exceeded 700 permanent losses that were not replaced. American tanks lost totaled 400 plus, but most were replaced within a week. The German tank force in the West was permanently crippled by the losses. After the Battle of the Bulge, German tank strength in the West declined from 1,400 to 700 operational tanks. This number continued to decline as production could not match losses. American tank strength actually increased after the Battle of the Bulge. American production exceeded losses, and replacement tanks arrived continuously from the United States. German General Otto von Manschufel wrote after the war, "The Battle of the Bulge demonstrated the futility of superior tank tactics against superior tank quantity. We achieved every objective of tank warfare. We destroyed more enemy tanks than we lost. We achieved breakthrough penetrations. We maneuvered successfully. And we lost the offensive because we could not replace our losses, and the enemy could. In the end, it is not the quality of weapons that determines victory. It is the replacement rate." Total tank production during the war from 1939 to 1945 shows Germany produced 27,339 Panzers of all types, including 1,347 Tiger I tanks, 6,000 Panther tanks, 8,600 PZ-4 tanks, and 11,392 earlier PZ-3 and earlier types. The Soviet Union produced over 100,000 tanks, including 53,000 plus T-34 variants, 5,000 KV tanks, and 4,000 IS Stalin tanks. The United States produced 49,234 Sherman tanks and other medium tanks, plus 10,000 light tanks and tank destroyers for over 60,000 tanks. Britain produced 4,600 plus Churchill, Cromwell, and other tanks. Total Allied tank production reached approximately 165,000 plus tanks. Total German tank production reached 27,339 tanks. The ratio was 6-1 in favor of the Allies. Monthly production trends in 1944 showed American production of 12,000 plus Shermans per month compared to German production of 400 to 500 tanks per month, a 25-1 ratio. In 1945, American production of 800 Shermans per month compared to German production of 200 to 300 tanks per month created a 4-1 ratio. By March 1945, with the war clearly lost, Germany attempted desperate measures to increase tank production. Despite maximum mobilization, German production never exceeded 600 tanks per month. American production, even after reducing priorities for tank production in late 1944, easily exceeded this. American replacement strategy was straightforward. When 10 Shermans were destroyed in combat, replacement occurred within 7 days. Tank crews and trained replacements were continuously available. German replacement strategy faced critical differences. When 2 Tigers were destroyed in combat, replacement required 4 to 6 months. Tank crews and trained replacements faced critical shortage. A German Tiger lost in December 1944 would take until April or May 1945 to replace. By that time, the war was effectively over. An American Sherman lost in December 1944 would be replaced by January 1945. German military leaders grasped the fundamental problem but couldn't solve it. General Heinz Guderian, Inspector of Armored Forces, stated in May 1944, "The Tiger tank is superior to any Allied tank individually. However, the enemy produces 3 new tanks for every one we produce. The enemy can afford tank losses. We cannot. In a war of replacement rates, superiority of individual tank quality is irrelevant. We need to produce not better tanks, but more tanks. This is economically impossible given our current industrial capacity." General Otto von Manschufel, 5th Panzer Army commander, stated in February 1945, "I have commanded Tiger tanks in combat. I have seen them destroy Sherman tanks with ease. I have also seen American forces respond to Tiger presence by committing 10 Shermans to every Tiger. We destroy 8 of them. 2 Shermans survive and continue the attack. We have 1 Tiger fewer. Within a week, they have 10 new Shermans. We have 0 new Tigers. This mathematics is immutable." Field Marshal Erich von Manstein, German commander-in-chief, wrote in 1946 while in captivity, "History will record that Germany lost the tank war not because our tanks were inferior, but because we were outnumbered. Our Tiger tanks were superior to any Allied tank. We lost because the enemy could replace losses faster than we could produce tanks. One needs not the best weapon, one needs enough weapons. Germany made superior weapons. America made enough weapons. In industrial warfare, enough weapons always defeat superior weapons. American commanders rapidly adapted to Tiger tank presence by developing tactical solutions that exploited American numerical advantages. General Omar Bradley, commander of the 12th Army Group, stated in 1945, "The Tiger tank is a superior machine to the Sherman. This is irrelevant to our operations. We commit multiple Shermans to every Tiger. We lose 3 Shermans for every Tiger destroyed. This is an acceptable exchange rate because we can replace 3 Shermans in a week and the Germans cannot replace 1 Tiger in 3 months." Tank combat is no longer about individual quality. It is about logistics, replacement rates, and industrial capacity. We win not because our tanks are better, but because we have more tanks and can replace them faster. General George S. Patton, 3rd Army Commander, stated in 1944, "The Sherman is not the best tank in existence. The Tiger is better. However, I do not need the best tank. I need a tank that I can produce in enormous quantity, supply with fuel and ammunition, and replace quickly when destroyed. The Sherman meets these requirements. The Tiger does not. I would rather command 10 Shermans than 2 Tigers." Mathematics confirms this preference. The Tiger I tank represents a principle that extends far beyond World War II tank warfare. In industrial warfare, quantity defeats quality. This principle held in tank warfare with Tiger versus Sherman. It held in fighter aircraft with Me-262 versus P-51 Mustang. It held in bomber operations with German bombers versus American bomber fleet. It held in logistics with Red Ball Express versus German supply lines. It held in production capacity with American factories versus German factories. The Tiger I was technologically superior to the Sherman in almost every measurable way. The Sherman won not because it was better, but because there were 36 Shermans for every Tiger. Modern warfare is fundamentally mathematical. Production rate matters more than individual quality. One superior weapon cannot overcome 10 inferior weapons. Superior quality provides tactical advantage. Superior quantity provides strategic advantage. Strategic advantage determines wars. Replacement rate is decisive. The side that can replace losses faster wins. Germany could not replace Tiger losses. America could replace Sherman losses within a week. Replacement rate becomes the limiting factor in warfare. Industrial capacity determines war outcomes. Germany could produce 500 tanks per month. America could produce 1,200 tanks per month. The difference compounds over time. After 1 year, America has 8,400 more tanks produced than Germany. Logistics determine tactics. Germany's fuel shortage limited tank operations. America's abundant fuel enabled continuous operations. Logistics become strategy in industrial war. The side with superior logistics wins. After the war, military strategists across all nations absorbed the lessons of Tiger versus Sherman. Soviet tank doctrine adopted after 1946 emphasized numerical superiority and mass production over individual tank quality. Soviet forces would produce T-54s in quantities that exceeded Western production. American tank doctrine adopted after 1946 maintained numerical superiority through continuous production. America would accept higher individual tank losses in exchange for maintaining operational superiority. British tank doctrine recognized that Britain could not outproduce Soviet or American forces. Britain would develop specialized tank roles rather than competing in numerical production. German tank doctrine, adopted post-war by West Germany, would develop qualitatively superior tanks while accepting numerical inferiority. West Germany would rely on NATO allies for numerical strength. This principle applies across military systems. 10 good fighters defeat one perfect fighter. Multiple conventional ships defeat one superior warship. Quantity of trained soldiers defeats small elite units. Production of weapons matters more than individual superiority. In modern warfare, attrition warfare favors the side with superior production. Superior quality provides only temporary advantage. Industrial capacity determines long-term outcomes. The economically stronger nation wins. The Tiger I tank remains one of history's most formidable military machines. German engineers and builders created a weapon of exceptional quality. Yet the Tiger I also remains history's perfect example of how superior quality cannot overcome industrial inferiority. 1,347 Tigers were produced. They achieved extraordinary kill ratios. They won tactical victories. They demonstrated German engineering excellence. And they lost the war. 49,234 Shermans were produced. Most were destroyed or damaged. They rarely won tank-to-tank engagements against Tigers. Yet Shermans won the war. The enduring lesson states this clearly. In wars between industrial nations, the nation that can produce more weapons of sufficient quality wins. Superior quality is an advantage. Sufficient quantity is a necessity. Germany learned this lesson too late. The victorious Allies learned it well. It shaped military strategy for the next 80 years and remains relevant today. In industrial warfare, enough is more important than best. Quantity defeats quality. The numbers always win. The Tiger I is history's most eloquent monument to this mathematical truth.